Thanks for joining me for our discussion of hygrometers. We're working our way through humidity measurements, and we are talking about the different types of sorption type sensors, meaning that they either adsorb or absorb water, and as a result, their electrical properties change. So we're looking at electrical hygrometers. In a previous video, we looked at how capacitance changes with increasing relative humidity in capacitance type devices. Now we're going to talk about electric hygrometers that are based on the principle of resistance, meaning that as water vapor is absorbed by these instruments, the resistance changes, and it may either increase or decrease depending upon the type of sensor. So the first one we're going to look at is the bulk polymer resistive sensor. And this is a device that has an inverse relationship between relative humidity and resistance, meaning that as water vapor increases, the resistance decreases. So this is a little chip that is put in a circuit, and that chip has a polymer, and that polymer absorbs water vapor from the atmosphere. As it does that, the volume increases, and so the water vapor acts as an alternate path to the electric current so that it doesn't have to flow through the polymer, but it flows through the little water molecules that are in between the polymer. So it acts as a conductive path. So as the water vapor increases, the molecules allow for conductivity, and as a result, the resistance decreases. So this is our chart that shows how resistance changes with relative humidity for the bulk polymer resistive sensor. Notice that it decreases, and it looks like the resistance is actually pretty decent, pretty big resistance, so it's easier to measure, but it does decrease. And there are some problems with relative humidities below 20%. It's difficult to measure that high resistance with low relative humidities. There's another type of device called the carbon hygrometer. And the carbon hygrometer, if you are an old and crusty meteorologist, this is your tried and true method for measuring water vapor in the upper atmosphere, because carbon hygrometers were used in radiosondes for decades. The carbon hygrometer has a definition straight out of the glossary of meteorology, and it's an electric humidity sensor element that's used in radiosondes. It relies on changes in the resistance of a humidity-sensitive component. And this humidity-sensitive component is actually a little glass plate, or almost glass plate. I'm not sure exactly what they use, but I know it is some sort of a little plate that is coated with carbon grains. And as this plate absorbs, as the carbon grains absorb water vapor from the atmosphere, the distance between the carbon grains increases, with relative humidity. So that means that the electrons can't flow through this polymer or this carbon as easily. So as the relative humidity increases, the resistance increases. So here's a plot of it. Notice that it is not linear. It looks like it is a bit of a curve. And there are some problems, quite a few problems with the carbon hygrometer. Number one, does have a high drift rate. It's only for short-term use. You can't use it over and over again. So once you open up the can, actually these were shipped in cans, almost like a can of soup, to protect them from the environment. So when they were sealed up, they had a particular relative humidity or moisture content. When you open it up, you have to use it right away, and you have to calibrate it before you send it up on the old radiosonde. But these are really cheap. Since they're made of carbon, they're relatively cheap. As I said, must be sealed, and you have to do a calibration or a baseline check before each flight. So they're small, they're very inexpensive, they're great for remote measurements. You can throw them away pretty easily. They do, as I said, require calibration, and there is some hysteresis, so there is some error with this. And they do have long leg time, so in other words, it takes longer to respond, especially at very cold temperatures. So that's your electric hygrometers that are based on resistance, and I hope you enjoyed it.